Heyo, welcome to this tutorial. In this one, we're gonna make a Gaussian elimination calculator. So I'm obviously gonna assume you know what like matrices are and what Gaussian elimination is and what reduced row echelon form is. So, but before we start, we should probably understand the logistics of how we're gonna actually make the calculator. So the way we'll start is we'll just imagine each row as like its own each row as its own separate vector, so that way we don't have to deal with multi-dimensional arrays. So that's gonna be alright, and we're gonna I'll just pull up this example first to start with. So in this example we have three variables: 3x plus y minus z, x, y, and z. So for example, we have 3x plus y minus z equals 1, and this is this standard way for we set up a matrix for Gaussian elimination with our variables here. So whatever is in front of a variable and all that. And eventually, once you get it to this form, 1 0 0 0 1 0 and 0 0 1, and it will go on like that. So if it's like 4, then it's going to be 0 0 0 1 and so on. You know how it's done, I hope. So the way we will go about this is, because we know that this value here is not going to be 0, it's going to be whatever, it's going to be a value aside that is not going to be 0. We're going to be using this value here to turn the other values into 0, and then we go to the next one, and then we are going to turn in this column these values to 0. And the way we go about this is, for example, in this example, we know we're going to transform row 2 into row 2 plus row 1, but we're going to multiply row 1 by the value here, so the row 2's value on there, and that value divided by row 1's value there. And then for row 3, that will be row 3 plus, so it's not going to be 1 now, so it's going to be negative 2 over 3. Well, actually, I should probably, this is a very misleading way to say it. I guess it's going to be more so like more so just like a minus here. So I'll just do that. Why not? So and then once we're done with the row 3, these are gonna be these parts are gonna equal to 0, and these values are obviously gonna be changed here. But that's what we want. We want to turn these into 0, and then we're gonna turn the value up top there to 0, and then the value down there to 0, and so on and so forth until we are done with our matrix. So now let's get to the actual programming part here. So I'm gonna be using C++, but hopefully if you're not using C++ and you're using like another program language, then hopefully this should be easy enough for you to understand what's going on. So there isn't too much C++ lingo. So and in case you don't know C++, this is basically how I print something out. But writing std and then the 2 colons and then cout is too much. So we're just going to be using, we're just going to say using namespace standard. So normally you're not supposed to do this because reasons, but we're just going to completely ignore those, so that's fine. So now we can just, so now we don't have to type std colon every time I want to print something out. So that's step 1. Step 2 is to actually make our matrices, I would say. So the way we're going to do that is, again, as I said before, we're not going to use multi-dimensional arrays. So we're just going to have our vector here, and we're just going to have vector. It's going to be a vector that has the data type of double, and it's going to call matrix 1. So if you remember our example here, it's going to be 3, 1, negative 1, and 1. So here, I'll just write that. 3, 1, negative 1, and 1. There you go, fantastic. So we're just gonna do this 2 more times. Okay, so now that we did that, let's actually make a function for us to print out. Now in C++, there's a little thing called operator overloading that we could use, but I'm pretty sure that's not in like, you know, some program languages that you might be using. So it might be, I'm not too sure if it's C++ exclusive or something like that. So we're just gonna go more conventional, and I'm just gonna make a function just to print our matrices. So we're just gonna say avoid print matrix. So obviously we're gonna actually want to take this vector double there, v. Fantastic. So first of all, we're gonna want to print out a bracket like so. The way that will look nice, I think. And now we're going to want to loop through our vector, obviously, so that we can get each value bit by bit. So I is equal to 0. I is going to be less than v dot size. Again, if you don't know C++, that is how you get the length of our vector. So there we are. Fantastic. So we're going to print out the elements of v like so. And yeah, we should also put like a few rules here, I think. So I'm going to say if I is less than v dot size, I believe it should be -2. You're going to you'll see what I'm doing in a second. I'm just going to put a comma and spacebar, so that way we can oops. So that way it will look nicer when we print it out. So Control X. And else if I'll say I is less than v dot size -1. Let's print out like a line there. You know how in a let's go back to our example. How there's that line there. We're just going to emulate that with that. There we are. And last but not least, once we're done with all that, print all that out, we're just going to say, oops, square bracket. And yeah, this should hopefully work. So we're going to say print matrix. And let's just try printing out matrix 1, like our first matrix. So let's see how this looks. Yeah, so here. I'll just put a little /n there so we go to a new line as well. Okay, so now we're printing out like each part here. So we're going to get to the main brunt of it now. So what we're going to want to start out with is going back to our example again. Let's just start out with when we're in the first row there. Let's just start out with making these two 0. So yeah, all right, let's do that. So obviously we're going to want a loop. But this isn't going to be the outer loop because it's going to be a bit of a mess with the loops. But I'll just start with F for now. We'll pay our respects to programming. Yes. We're going to want to put all of these matrices into one big boy matrix. Sorry, all these little vectors into one big boy vector. So we're just going to say vector with the value of a vector double. There we are. And we're going to call this matrices. Matrix 1, matrix 2, matrix 3. There we are. So then we're going to say f is equal to 0. F is going to be less than matrices dot size and f plus plus. Yeah, There we are. So now that we have that, I think, yeah. So obviously we don't want to change any values of matrix 1. So again, for now, this is going to be the final thing. We're just going to say if f does not equal 0, then we're going to continue. Then we're going to open up another loop. And let's call this j. For integer j is equal to 0. J is going to be obviously, again, less than matrices dot size. And j plus plus. Yeah. Oops. J plus plus. Fantastic. Oh no. J. Oh, for the love. J plus plus. Perfect. Finally. After like 20 attempts. Jiminy. Alrighty. So now that we have that, first of all, we're going to want, because we're going to be changing the values, for example, we're going to be changing the value of our 1 to 0. We're going to want to record this being a 1 before it's changed. So to do that, we're going to create a little if. If j is equal to 0, then we're going to create a little value. I think let's call this, yeah, it's going to be a double. We'll say, we'll call dividend. I think it's dividend with a D at the end. So that should do fine. So if j is equal to 0 there, we're going to say dividend will equal to, so it's going to equal to the, yeah, it's going to equal to 3. So we're going to just say matrices. We're going to say f. And then we're going to say 0 there. So that's going to be divided. Wait, hold on, let me think. Oh, wait, no, sorry. So it's going to be 1 divide, so it's going to be like this matrix 2's value there. So matrix F0 will be getting that for us. And then we're just going to divide that by, yeah, matrices 0. 0, so that way it's just going to be us. Oops. It's with an n, right? Yeah, well, it's with an n. Okay, there we are. Very nice. And now what we're going to do is we're just going to, here, let me think. Yeah. So then we're going to change the values here. Matrix. So we're going to be changing our, again, I'll just grab our matrix example. So with this fj, because we're going to be looping through this, so the j is going to be going like this basically, and f will be here, and then j is going to be here, it's going to be here, it's going to be here, it's going to be here, and then f is going to move down, and it's going to be here, and it's going to be here, it's going to be here, and it's going to be here. So let's do that. We're going to say matrices fj. So we're going through those one by one. We're going to say it's going to be minus equal to the values here. So we're going to, so whatever, yeah, so whatever our dividend variable is, it's going to be multiplied by the values here. So let's write that. So it's going to be matrix fj. It's going to be minus equal to matrices. Our first matrix there. Obviously, we're going to be changing this because we're going to want n by, because we've got to change the other variables as well, otherwise it'd be a bit ridiculous. So matrices 0, and then we're going to say it should be I believe. I believe. Multiply by our dividend. And let's print matrix. Actually, here, hold on. Let's turn this into a for loop shenanigan thing. So we're gonna say for integer I is equal to 0. I is less than matrices dot size. Oops, I plus plus. So there we are. We're gonna say print matrix matrices I. Okay. It should be it, I believe. Let's see. Let me see. No, okay. It appears that I'm doing something wrong. I'll be right back when I figure out what I'm doing wrong. Okay, and we're back. So I made a mistake. Here it was F. It should have been J. So there we are. Now this loop cycle has changed it there. So now it's just 0, 0. And now, but obviously you're going to want to do it to the rest of them. So we're going to use this negative 1.33 to change the value there and to change the value here. And then we're going to use this 1.6667 to change the values here and here. I mean 1.33 and the negative 1. Alrighty, let's get to doing that. So now we're going to have another loop to do that. So we're going to say integer I is going to equal to 0. Standard. I is less than matrices dot size and I plus plus. So let's do it like this. Oops, matrices. Actually, is it matrices? I just always assumed that it's matrices. It sounds right. Well, hopefully I'm correct. Whatever. As long as you understand what's going on, that's fine. Who cares? So I'll just go down there. Yeah, I think that's good. And yeah, okay. So now the first part is we have it when we said f does not equal to 0 because we were cycling through here, if you remember. And this was our 0th. This is our first. This is our second. But now it's not going to be like that. Now we're going to say if f does not equal to I, like so. And now, actually, hold on, let me think. The dividend does not need to be there. Yeah, no, it does not need to be there. So we're just going to yoink that dividend thing there. It does not need to be there. So we'll just plop that on there. And now the way we're going to measure our dividend value. Hold on, I'll just erase these. So we're going to measure our dividend values. Obviously, we're not going to have like these zeros here. So it's going to be, instead of this, it should be matrices fi and then II. So if you're wondering what a matrices II will be, so it's going to be this one here, and this one here. There we are. Okay. And as for our for loop with the J thing there, instead of Fj, we're going to say Ij. Multiply that. Now, when I run this program, we should get something a lot closer to what we think of when we say row echelon form. Obviously, there is still one part missing. That part, of course, being us needing to divide these values. So, for example, here. Wait, hold on. There seems to be a problem. Be right back. Okay, and I'm back. So, I figured out what the problem is. It's a bit ridiculous, but so for the J, because we're cycling through, I know why I didn't think of this before. So because we're cycling through each of our each part here with J, it should have been matrices F. So we're gonna have the square bracket. So we're getting the size of however big this is gonna be. So currently it's 1, 2, 3, 4 variables. But if it's like a 4 by, if you're doing like a 4 by 4, if you're doing like a 4 variable solving, it would have been 5 values, so on and so forth, right? So we're going to want matrices f dot size. There we are. And so when I run that now, yeah, it's going to look like this. So obviously, there's one more issue. We're going to need to divide this negative 1.5, so this is our current solution, by whatever is there. So fortunately, doing that is going to be really easy. I mean, okay, I'm sorry. That's just inviting karma. Watch as I write this in. I get another problem. So I is going to be less than matrices dot size I plus plus. So there we are. So the way we're going to do is we're going to get our matrices I, so yeah, I, and we're going to get our last one. So however big our matrix is going to be, matrices dot size, we're going to say, is going to be divide equal. So we're going to divide it by the matrices I should be, and then we're gonna need to divide matrices II captain by matrices II, and let's run that. There we are. So now we have turned those initial matrices into reduced row echelon form, with the ones only being diagonal like so, and the zeros being there. And as like a side-by-side comparison, I'll just print it out here before we do all that Gaussian elimination processes. Okay, hold on, let me just put a little. I know that's not how you're supposed to really do it, but I'll just put like one extra space so you can see it better, like the difference. So this is our this is our matrix before, and obviously we separated the matrix into the vectors there, and then this is it afterwards. And yeah, that's basically it. And it's working pretty well. Yeah, I got we could also try like a 4x4 to show you it's not like it's not just dependent on it being like a 3 variable thing. So we could also do that. So I'll just get this. I'll be right back when I have a whole bunch of matrices for that. Back. So let's see. I'm using this random example I found off the internet. I'm just gonna run it, make sure it's working. Okay, and I believe the answer is yes. So let me see. Yes. Yeah, okay. So here we are. We have these matrices here. So 4, 5, 6, 7. So it's like this before, and then we just turn it into that. And the example I found off the internet is this one here. There we are. So now, instead of when you get like a 4x4 matrix and you're trying to solve for like 300 minutes, but then you mess up one negative sign and then you get 0 marks for it, you can just use this calculator and get the correct answers immediately. And yeah, okay, that's it. Take care. Goodbye.